Okay, we are at example 4, and this is going to be a geography question. And it says in your notes you can use radians to compute distances between two cities that lie on the same longitude line. And this is the real world application on 246. So if you need to, push pause and go to your book to 246 so that you can read this problem. Winnipeg, Manitoba, Canada, and Dallas, Texas lie along the 97 degrees west longitude line. The latitude of Winnipeg is 50 degrees north, and the latitude of Dallas is 33 degrees north. The radius of the Earth is about 3,960 miles. Find the approximate distance between the two cities. Okay, I'm going to draw a picture of this on the circle. And I'm going to have, there's the center of the Earth. Okay, the Earth is green. And I'm going to have the distance, and I'm going to have two cities here. This is going to be, let me draw this again. I want this to be the equator. That's our radius, which is 3,960. That's our radius. And then we have the distance between these two cities. We've got Dallas and Winnipeg, Manitoba. Now, Dallas is 50 degrees, and Winnipeg, Manitoba, actually Winnipeg is 50 degrees. So this angle is Winnipeg, Manitoba, that's 50 degrees. And this angle right here is Dallas, and that is 33. Well, we need to find how far apart these two distances are. And in order to find that, I'm going to need to subtract Winnipeg minus Dallas to find how far apart they are. Because if this is the equator over here, and this is Dallas, and this is Winnipeg, I need to find the distance between these two cities, which is actually this arc right here, is the distance between the two cities. So I need to find the distance between those two angles. So 50 minus 33 degrees is going to give me the angle of 17 degrees. So that means right here is 17 degrees. So now I need to calculate, I want to do S is equal to R theta. R is the radius, but my problem with the theta is it's 17 degrees. I need it in radians. So I'm going to have to come over here and convert 17 degrees into radians. I'll put 180 degrees on bottom, pi on top, and I get rid of the degrees, and I'm left with radians. Okay, so that gives me 17 pi over 180. That doesn't reduce. Okay, no, the degrees is marked out here. Alright, so I'm going to plug that into my problem and put it in my calculator, and I will have calculated the distance between the two cities. Now the equator was in miles, so my answer will be in miles. So the arc length of this 17 degree angle is 1,174.9556, etc., which I'm going to round that just to the nearest mile, which is 1,175 miles. So that is the distance between Dallas, right here, and Winnipeg, Manitoba. So I subtracted, and then I changed the degrees into radians, and then I plugged it in with the radius, and I got my S, which is 1,175 miles. Next in our notes, it says a sector of a circle is the region bounded by the central angle and its intercepted arc. I'm going to show you what a sector is. A sector is like a piece of the pie. it includes everything. It includes the crust and all inside. It's like a piece of the pie or a piece of the puzzle. And so the sector of a circle is a piece of the circle. I am going to show you how they derive this formula. Alright, and it's kind of like the last time. We just want to know how they derive the formula. How did they just make it up? No, they derived it. So I'm going to show you how they derive it. This right here is 0. This is r for radius. This angle is theta. And this is big R, part of the arc. Here's a point T. And this right here is point S. And so we're going to set up a proportion to find the area of the sector. And first we're going to compare it to the area of the whole circle. So if you do area of the whole circle, which is equal to pi r squared, that's how you find area. And it's in direct proportion to, now this is the area of the sector. Area of the sector over the area of the circle. That's part over the whole. Part of the circle over the area of the whole circle. Over what we just know, we already know how to find the arc length. Okay, but this is the length. The length of RST. And that's this, the crust or the arc, over proportional with the whole circle around the circle, which would be circumference, pi r squared. So let's look at what we just did here. We did the area of the sector is equal over the area of the circle, and that's a proportion, maybe 1/2, 1/3 of the circle or whatever. And this is the length of the arc over all the way around the circle, the circumference. So I'm setting up a proportion, and the whole point of this is not to worry and fret. We're just learning how they come up with it. The length of RST is the same thing as r theta, because that would be your S, or the arc. So I'm going to rewrite this. The area of a sector is equal to r theta, pi r squared's on the bottom, and 2 pi r. So all I did was plug in this S with r theta. Okay, I'm going to take the cross product and solve for the area of S. That's a little sub S, but it's the area of the sector. So the area times 2 pi r is equal to pi r squared times r theta. Now all I did was take the cross product because I knew that these proportions are equal. And now I'm trying to solve for this area of a sector so that I can get the formula for the area of a sector. So I divide by 2 pi r on both sides. And I want you to notice some things will cancel. Pi is going to cancel in one of the r's. And what I'm left with is r squared theta. Now remember, theta has to be in radian mode, all over 2. So I can rewrite this. The area is equal to 1/2 r squared theta. So this is how we find the area of a sector. So in our notes it says that area of a circular sector, if theta is a measure of the central angle expressed in radians, theta's got to be in radians, and r is the radius of the circle, then the area of the sector is as follows. And that's the formula that I just gave you. Let me rewrite this. So its area is equal to 1/2 of the sector. I'm going to put a little s there so we know what to find the area of. The area of a sector is equal to 1/2 r squared theta. And remember that theta has to be in radians. Alright, well let's look at our last example. Example 5. It says find the area of a sector with the central angle measure of 5 pi radians. It says central angle measure, so that has to be our theta. If I was going to draw a picture of that, it would be a circle, and 5 pi over 6 is going to be our central angle. And they told us the radius is 16 centimeters, and they want us to find the area of the sector and round it to the nearest tenth. So we're going to take 1/2 the radius, which is 16 squared, times 5 pi over 6. I do not have to convert this to radians, it's already in radians. So when you put that in your calculator, you're going to get area is equal to, of the sector, is 335.103, and this is centimeters, so that would be centimeters squared. Now I'm just going to round it to the nearest tenth like the directions say, and it's 335.1 centimeters squared. Alright, we've covered a lot. Let's kind of just go back and look. This first example was showing how we could use this formula for arc length to find the measure between two cities. You will have a word problem that we will work on like that, where you have two cities and you have to find how far apart they are, which is the arc length. Okay, we learned how to derive formula. I think I skipped too far. We learned how to derive the formula for area of a sector. We took a proportion and found the area of a sector, which is right here, 1/2 r squared theta. Then we took that formula for an area of a sector and we found the area of this sector here. Okay, it's like a piece of the pie or a piece of the pizza. And we found the area of the sector. Alright, thanks.